Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at another version of the mean value theorem, and this basically is Cauchy's mean value theorem. Now, from our previous discussion, we had basically mentioned that the mean value theorem is going to be giving us the relationship between two particular points of a function. And as of course mentioned, these are going to be points of a function which we can consider in terms of this specific illustration, which is going to be given in terms of f of x. Now, suppose this function which is given as f of x is continuous over a closed. So now suppose this function is continuous over closed intervals over a and b and differentiable over the open intervals of a and b, then there is a point C between a and b, which we can give in terms of a. So this is going to be a between a and b, such that this specific point for the first derivative of this specific point b is the same as f of b minus f of a all over b of a. So in this particular case, this mean value theorem of course gives a function which is continuous over closed intervals over a and b, and differentiable over the of course open intervals over a and b, and then there is a point C between a and b such that the first derivative of a and b is given in terms of this specific representation. And then we went ahead and tried to of course give the relationship between this specific point C in a general way, whereby we came up with a specific of course description for the mean value theorem, which we gave in terms of fx minus fa is equivalent to fb minus fa all over b minus a into x minus a. And this basically gave us the relationship for representation of these specific points and the intervals which we had just mentioned for the two intervals of a and b. Now, in this particular case, we're going to look at a version of the Cauchy's mean value theorem, which in contrast to the first one is going to consider two functions, perhaps of y, which is f of x, and another one g of x. And we're going to see how we can illustrate this specific aspect of the mean value theorem in terms of those two functions. And this is going to be the concept of the Cauchy's mean value theorem. Now we are going to consider this specific case whereby we are going to have two particular functions, which I'm going to give in this specific form. So we shall have this one given in terms of so we're going to have suppose that the functions f of x and g of x are continuous over closed intervals. So I'm just going to give this one as such. So suppose two functions f of x and g of x are continuous over closed intervals of a and b and are differentiable over open intervals over a and b, then there is a C, which is a point between a and b, such that the first derivative of course f, the function of f given as such, all over the first derivative of the function of g given as that one is equivalent to this specific value of fb minus fa all over gb minus GA given as such. So this is going to be a representation of the Cauchy's mean value theorem, which can be given as such. And of course, we can just try to give a confirmation of the same whether this is going to be true, especially for the previous discussion which we have just done. Now, in this particular case, just given an implication that this is going to be the case. And of course, we can just have a short summary of what we had just discussed in trying to see whether, especially in discussion of rational functions, are just given an implication that we can do a simplification of such a kind of an equation and try to show that basically that's going to be the same. So in this case, I said that we can have the first derivative of a specific function given as such for a point over a and b, between a point over a and b, by giving this one in terms of fa all over fb divided by divided by b minus a, and we can give a derivative of this specific function given in terms of gb minus ga all over b minus a. And in this particular case, this gives an implication of the functions that if we have fx all over gx prime, f prime g prime with respect to x, this is going to give us an implication of this fb minus fa all over b minus a. And this is going to be a division of this specific, of course, second function which we are going to have. So this is going to be representing our f prime over x. So we're going to have a division of this one. So this basically, I'm going to just to do a multiplication and flip off this one in order for us to have a reciprocal of that one or an inverse of that one, gp minus g of a. And of course, these specific factors are going to cancel out, and we're going to have this a particular, of course, a function given in terms of fb minus fa all over gb minus ga given as such. So this is going to be giving us an impression that we're going to have this one given in terms of x. And this, of course, is going to be a version of the Cauchy's mean value theorem, which states that if we have two functions, f of x and g of x, which are continuous over the closed intervals over a and b, and of course differentiable over open intervals over a and b, then there exists a c between a and b such that of course the first derivative of this specific function given as fc of course over c gc can be given in terms of fb minus fa divided by gb minus g a given as that. So this is going to be an analogous form of this specific, of course, evaluation which we have done. And of course, we're going to consider whether that is going to be basically the case from the mean value theorem. So in this case, I'm going just to do away with this. And then we will confirm whether basically if we have those specific two functions according to the Cauchy's mean value theorem, is it going to be the same that f prime over c, g over g prime over c is equivalent to the derivative of that specific function. So in the first place, I'm going just to quote this specific, of course, Cauchy's mean value theorem, which we are going to have in the form of this specific representation given as such. And we're going to have this g of b minus g of a given as such. So in this particular case, we're going to consider trying to give this specific case for the function of gb is not equivalent to ga. So suppose we have a gb equivalent to ga, then that's going to give us an implication that of course g prime over c is equivalent to gb minus ga all over b minus a. So if these are going to be the same, then this implies that we're going to have a 0 over b minus a, implying that our denominator is going to be equivalent to 0. So in this case, we are going to consider a condition whereby we are going to have these specific values for the function of g are not equivalent, which are going to be gp is not equivalent to ga given as such. Then we're going to apply the mean value theorem in this specific function, which I said that we are going to have the mean value theorem given in terms of fx minus fa is equivalent to this specific form of the function over fb minus fa all over b minus a. And of course, we had this one as well given in this specific format over x minus a given as such. So we're going to consider a version of this specific, of course, two functions. This is going to be a single function which we had to consider for the mean value theorem of y is equivalent to fx, and we had to consider two intervals for this a and b, and this is going to be giving us a version of the mean value theorem given as such. So if we consider Cauchy's a specific two theorems which we have said, then therefore we are going to have this specific function given in terms of fx equivalent to the values of fx minus fa, and this is going to be given in terms of this derivative of fb fa all over gb minus ga given as such, and there's going to be a difference between this gx minus ga given as this. So this is going to be a version of this specific representation for the mean value theorem of these two functions. And if this particular function is continuous on closed intervals over a and b and differentiable on a and b, then we can have this version of the equation given for the, of course, case of this specific part for a and b. And then therefore we are going to see that we can have f a given in terms of this specific representation, whereby we're going to have fa minus fa is equivalent to fb minus fa all over. So this is going to be all over this specific part of the, so we're going to consider this specific function for x as a, and of course we're going to put this one in this particular version of the of course Cauchy's mean value theorem, and try to see the version of this specific equation what is going to give us. So this is going to be gb minus g of a, and then we shall have this one given as times gx minus g of a given as such. So in this case, for our x, this is going to be represented by this particular value of a. So we shall have ga minus ga given as such. So if we try to see this one, the evaluation of this one is going to be giving us a 0, equivalent to this ga minus ga, that's equivalent. And therefore, we're going to see that this particular value for fa is going to be 0. Now, suppose we consider the value of f, of course, b on these other intervals, and try to see what is going to be the value for that one. We're going to have fb represented as the function of fb minus fa is equivalent to fb minus fa all over gb minus ga. And of course, we're going to have this other value for the function given in terms of gb minus ga. So this is going to be the mean value theorem, which is mean value theorem in terms of the mean value theorem, a general representation for the mean value theorem which we have given in this particular case, by trying to consider the two functions instead of this specific one function which we had of course said in terms of fx given as such. So in this case, we're also going to look at this one, and we're going to see that the numerator for this specific section of the right section of the equation is going to be, of course, the same for this. And as we see in doing a rearrangement of this specific equation, we're going to have a f of b brought to the other side, and we're going to have a f of a taken to the other side, and this is going to be equivalent to f of a minus f of a, and those basically is going to be giving us 0. So the two evaluations basically imply that f of a is equivalent to f of b, which is equivalent to 0. And this is going to be giving us an implication that by a Rolle's theorem, then at least there is that specific point over c, whereby the first derivative of this specific point with respect to c given as such is equivalent to 0. And in this case, we can consider, therefore, trying to represent this specific representation for the values of the derivative of fc, and try to see, according to the Cauchy's mean value theorem, what it's going to be giving us. So in a sense, we're going to have this one represented in terms of f prime over c equivalent to fc. And this is going to be giving us the values of this specific equation of fb minus fa all over gb minus ga. And the other side is going to be giving us this specific value of g prime over c given as such. So in this case, if we try to look at this one, we can just do a rearrangement for us to have this particular version of the equation given in terms of f prime over c divided by this specific factor, which is going to be giving us g prime over c equivalent to fb minus fa all over gb minus ga given as such. And this is going to be a version of the Cauchy's mean value theorem, which basically proves that if we had the two functions of fx and g of x, we can give their respective, of course, derivatives with respect to c given in terms of this particular, of course, evaluation for the derivative of that specific function. And that is going to be true, of course, for functions which we are going to consider, which are going to be two in number. So therefore, that's going to hold for Cauchy's mean value theorem. And we're going to consider doing some of the evaluations for this in order for us to confirm that basically that's going to be the same. So I hope that we have understood the procedure for this. And kindly check out description boxes for various links of other videos which we are going to be doing on the same topics. Subscribe to engage us in the comment section, and also ring that notification bell for more updates on our various uploads in math and sciences. So that is it for now, guys. Bye. God bless you. Catch us in our next video.